So, okay, let's start. I believe. Previous our week, we work with the basics of Java, and we talked about this course. Okay, I'm recording this our class, so it will be uploaded later in YouTube, and in our distance learning course you can find out this video, but later, not now, after about 1 hour after our class. We talked about elements of programming. Yes, how to compile, how to run program, and a few of your group submitted your laboratory work. Today we'll talk about data types and basic operations. At first, you told me, and you, according to our syllabus, you are acknowledged with the basic data types in C language. In Java, the names of the data types are very close to the C language, and also we have very close operations with these values. What are these values and what are these operations? At first, you see in this table you see all of them. You see all of the data types, and let's do it more let's do it in some graphical way. So at first we have primitive data types and reference data types. So two main classes of and reference data types. The main difference between them is that first one live in a stack memory, and reference data types live in a heap. Also, primitive data types are. Let's talk about primitive at first. Primitive are its integer values. What they are? It's byte, and size of it is size will be 1, yes, because it's byte. It's a byte. We have short, or maybe let's do it in programmatic way in an environment. So what about primitive data types? Int, its integer value. And we can declare it in this way. Also we have byte, byte from smallest to largest. Byte value equals to 1. Short value equals to 4. Also we have and sizes of it: 1 byte, 2 bytes, 4 bytes. Long, its long value, it's equals to this, but if you want to set some large value, you have to put at the end L, capital or small, but better to use L. Also we have float, like in C language. For instance, A equals to 5.1 or 11, and double, B equals to this one. Also you see that here we have error, because here you have to have put F. F means float. It could be capital or small letter. These are 6 data types. Also we have Boolean, Boolean data type. It's a logical data type, yes, and it could be true or false. So we have 7 data types, and also we have character data type. It could be integer value, like integer value. It could be represented as a character. Okay, let it be first, second, and also it could be a Unicode symbol. In this case you have to know which one Unicode symbol you will use, and use something like this. In this case you will have Unicode symbol. It should be 4 letters. It should be its Unicode symbol, and for instance, this is Unicode label, and among these symbols you can find out, according to the range, different symbols types. For instance, what it could be: basic Latin, that's okay, but let's find something interesting, which could be really interesting. These are some specific characters. Where these characters are? Okay, let's scroll down. Some specific characters. Oh, like this. Oh, for instance, this is very interesting symbol. Yes. Imagine that you want to. There are multiple different symbols in Unicode. I want to find out something pretty and rather interesting to show. Different national alphabets. Okay, let it be. We have, I see that this is very close to Greek, or not, I don't know, because, oh, okay, I spent too much time for, oh, Bitcoin, symbol of Bitcoin, yes, you see it. We don't have symbol of Bitcoin usually, so Bitcoin sign, very nice, and the code is 20BF. So what we do, you simply put here 20BF. It's hexadecimal code. And now also, what about double values? If you're talking about double values, we can use something like this. Also, or you can put E minus 5. It's exponent representation with a it means very small number, yes, and also it could be plus very large number. So okay, let me show you how it should look like and if you run this code, we will see the result. You see, this is Bitcoin, like a Bitcoin, but I see that maybe the font which print this is a bit different, but you can look through the this table I show you, yes, and you can see different and multiple options of so this is Unicode table. You can use it. This is, for instance, code of Bitcoin. So data types, yes, and sizes of these data types are 1, 2, 4. Also, the size of this data type is 4, and here is 8, and long is 8 bytes. Character is 2 bytes. So that's about these things, data types. Okay, now let's move to reference data types. And okay, operations which we can do with, like in a C language. Like in the C language, what we can do with these data types, we can add, we can subtract, we can subtract, we can divide, and we can find a model. Only let's do it with the integer numbers. And also, if you want to have a cast numbers, we are using casting. If we put the value between before the some value, in this case you see this variable is float, and if you put here int, then this variable will become int, and all of the values after the point, after the comma, will disappear. And also you have to understand that if you declare some value like that 4 equals to a, which is to b, you will see an error. Why an error? Because the size of b is 8, and size of z4 is 4, so we have to cast this value to float. You did it. And now this is casting. This is data types, and this is casting. Okay, let's move to our basics. Yes, and also we have reference data types. Also, you see here that there are different representations of numbers. I suggest you to look at this lecture, and here you will see operations. Also, we can use parentheses and do these operations in the parentheses. So these are the values, and these are the expressions you can use to obtain proper results. Now what about logical operations? Logical operations are not. This is not value. If before value was A was true, then not A will be false, and vice versa. Also, if we have truth table of truth, I believe that in the computer logic or other courses like computer logic, you have this table. You saw this table. If A and B are false, this operation E, this is logical E, and this is logical OR, and you'll obtain false, true, and etc. So these are logical operations, truth table. Also, we have comparison operations, which allows you to compare these values. That's also that's all of these operations like in C language. So you have some experience with the C language in courses before, in previous courses, and the same syntax used in all modern languages. So you can use it also, and you will use it in your programs. And now let's move forward and to print string we are using system out println. To convert from string to integer value, we are using integer parse int, double parse double, long parse long. Also, we have mathematical functions, is math. I'm only scrolling this, and in a few moments I will show you practical examples in the code. And these are functions from math function with explanation, short explanation. These are the short explanations. And type conversion, you see how to convert between different values. And also examples of different conversions. I believe that this small piece of information could be used by you as a cheat sheet for writing your second laboratory work. So you can use it as to have your laboratory work. So this is what we are doing now, yes, and now what we are doing, let's move to practical tasks. Exercise. Suppose that A and B are int values. What does the following sequence of statements do? Yes, so these are different tasks, but let's move to oh, now we have a very nice first nice exercise. Wind chill. Given the temperature T in Fahrenheit and the wind speed V in miles per hour, the National Weather Service defines the wind chill to be. We can look what is it, and this is the formula we have to use to calculate this, yes, and write a program that takes two double command line arguments T and V and prints the wind chill. Use math B to compute AB. Note the formula is not valid if T is larger than 50 in absolute value, or if V is larger than 120 or less than 3. You may assume that the values you get are in that range. So let's do. our task. I suggest, okay, I remove all these things and let's create, okay, let's make our program to make this calculation. At first we have to read command line arguments t and v and prints the wind chill. So we have to declare t and v. At first we declaring our values, double t, yes, and double v equals 0. At first we put it equals to 0. Then we have its temperature in Fahrenheit and speed, wind speed. Okay, the formula is this very large formula. Okay, what is the formula? Double this plus this multiplied by t plus this multiplied by t minus this value multiplied by, it's multiplied, yes, multiplied by v, but we should be in the power of, so we will use math pow function and we in the power of this. So we have this calculation. This formula, we describe this formula, yes, and we have some conditions. The formula is not valid if t is larger than 50 in absolute values. So if mass abs of a t greater than 50, yes, and other conditions. What conditions do we have? Of v is larger than if t is larger than 150 and in absolute value, or v is larger than 100 or less than 3. And what we will do, this is one condition, and this is another condition, and this condition will be about absolute value of v, math abs of v is larger than 120, and is less than 3. So we have this condition. So if this happened, we will do the next. We'll print on the screen this, and program will end. Return means that the program ends at this point, and in other case, what we will do, we will print wind chill equals to, we will do printf for this purpose function, equals to f if t equals and wind speed equals to if temperature equals to miles per second, then wind chill equals this value, yes, and move to next. Okay, and we put here temperature is a T, V, and W. So now you see that we have temperature. It will be substituted. T will be substituted in this position, in this placeholder. V will be substituted in this placeholder, and W, which we calculate here, will be substituted in this position, in this placeholder. So you can use these values. And what about these values? These values we should put from the keyboard as command line arguments. And what are they? What if you write power only without? Good question, Robert. Okay, how to live without all this long? Good question. Okay, let's simplify our code. Okay, agree. Good question. You can do this. In this case, what you will do, apps, for instance. But what happened here? Oh, just a moment. Sorry. Java lang math. This. That's okay. So if you do this in this way, Robert, good question. Then you can omit this. If you are doing static imports, but static imports you can use only in the case if the methods like pow and apps are declared as static methods. That's a good question, Robert. That's a good question. The next. So this is what we can do, and how we can read these values as command line arguments. Very simple. Very simple. If args length not equals to then and program ends. In other case, what we will do, we will do the next. We will do double, parse double, and we are using args 0. And in the same way, we will do the next. We will read value from the keyboard in this way. So you can use both. You can use both of these values. Now let's try to run this program. To run this program, what we will do here, we have run configurations, and we have here arguments, program arguments. What we will do? Program arguments. It will be okay. According to our to be correct for our program, the temperature should be greater than 50. Yes, so it could be, for instance, 70. And second one should be greater than 100. It couldn't be greater than, let's check again. So we have to put values not in this range, so it shouldn't be just a moment, it shouldn't be larger than so in the range between 3 and 120, so maybe okay, and 100, I believe it will be good. So show command line. Okay, so we will run our program this way. Run. And our program runs properly. You see this? That if temperature and you may ask me what to do, how to run this program not in IDE. Okay, I will help you also in this case. What we will do it very simple way. It's a command line prompt. Okay, first lab Java. So this is file of our Java first lab. Yes, first lab. I compile our code first Java C, and run my code first. Okay, I didn't use any arguments. What I will have? Usage. You see, yes, I didn't provide any arguments. And now I provide only one argument, also error. I provide 3 arguments, also error. Okay, now I provide these arguments, 4.5, 6.3. But we have a small error here because it wasn't checked. Sorry, it shouldn't be and, it should be or. It should be or. So let me also fix this in a code. We should put here or value, not e but or. And I believe here will also be and. Sorry, or. Let's do this. We compile our code and run it. The condition should be checked twice because it's not correct here. Let's Okay, in our case, if values are greater than 50, it will be error, and or absolute value is of wind speed is greater than this, or I believe this is okay now. Okay, let's check incorrect values. 0.5. Input values are incorrect, and input values are incorrect. And if values are like this, so this is correct. Now these are correct values. I don't know, it should be maybe in an absolute value, but nevertheless we calculate this according, maybe condition should be checked, double checked, but here you see an example of resolving this task. Your homework will be in resolving these tasks you see here according to your number in register, and I suggest you to resolve the next tasks here. It's a polar coordinates, day of the week, uniform random numbers, and 3 sort. Try to play with this, and maybe also this. At least if it's too complicated to resolve this task, because here we have to play a lot with this, you can use your own formula with calculation of some figure, geometric figure, and calculate square, volume, or other parameters of some geometric figure. Maybe have some questions.